Hi everyone. In previous videos I explained the general rules of derivatives, the derivative of trigonometric functions, logarithmic functions, and exponential functions. In this video I will review the rule of logarithmic functions and solve some problems. So if we have log of x to a base of a, the derivative is equal to 1 over x. So this is x, it will be 1 over x divided by ln a. If we have a function that is equal to natural logarithm of x, the derivative will be 1 over x. Here we can say over ln e, but e is equal to 1, so that's why we don't need to mention it because it's 1. So the function or the derivative will be just 1 over x. Let's here say we have a log of g of x to a base of a. So here we have a function with respect to another function, so we can apply the chain rule. The derivative will be equal to 1 over g divided by ln of a multiplied by the derivative of g. Whereas if we have a natural logarithm of g, the derivative will be 1 over g multiplied the derivative of g. So these are the rules of logarithmic functions. Now we can solve some problems. So I wrote some functions so that we will solve these functions in these videos. So let's start with the first function. Let's say we have a function that is equal to a natural logarithm of 3x minus 2 to power 2. So here we have a function that is equal, or a function that is equal to a natural logarithm of another function. So here we have the outside function and the inside function. So we'll apply the chain rule. Y prime is equal to 1 over the inside function, which is 3x minus 2 to power 2, multiplied by the derivative of the outside function. So it's 2 multiplied by 3x minus 2 to power 2 minus 1, multiplied by the derivative of the inside function, which is 3. So here I can simplify this derivative a little bit. So y prime is equal to, this is here is equal to 1. So I can divide this function with removing one of this power. So we'll have 1 over 3x minus 2 multiplied by 2 times 3 is 6. So it's equal to 6 over 3x minus 2. I have another function that is equal to a natural logarithm of 3x squared minus 6x. So again we have a function with respect to another function. So we will apply the chain rule again. So the derivative will be equal to, since we have natural logarithm, so it's 1 over this function, 3x squared minus 6x, multiplied by the derivative of the outside of the inside function. So it will be 6x minus 6. And this is the derivative. Problem number 3. A function equal to ln of cosine x. So here we have one function with respect to another function. So we will apply the chain rule again. Y prime will be equal to 1 over the inside function cosine x multiplied by the derivative of the inside function. And as we know, the derivative of cosine is minus sine x. Minus sine x. So this will be equal to minus sine x over cosine x. Of course, we can keep this derivative like that, or we can change it to a tangent. As we know, sine x over cosine x is equal to tangent. So this derivative, we can write it as minus tangent x. I have another function here. Here it's logarithm or log of x squared minus 3x plus 1 to a base 2. The derivative y prime will be equal to 1 over this function x squared minus 3x plus 1, and since here is base 2, that means I have to divide by ln of 2, multiplied by the derivative of the inside function, which is 2x minus 3. Let's solve another example about log with a base. So we have a function y equal log of x minus 1 divided by x plus 1 to a base of 3. So the derivative y prime is equal to 1 over this function x minus 1 over x plus 1 multiplied by ln of 3, since we have a base 3, multiplied by the derivative of this function. So here we have x minus 1 divided by x plus 1, so we'll apply the quotient rule. So the quotient rule is the derivative of the top function, which is 1, multiplied by the bottom function x plus 1 minus the top function as it is multiplied by the derivative of the bottom function, which is 1, divided by the square of the bottom function, x plus 1 square. We can simplify this function a little bit, so y prime will be equal this x minus 1 over x plus 1 in the denominator. I can just write it in this way, x plus 1 over x minus 1. And I have here 1 over ln 3, so I will keep the ln 3 in the denominator, multiplied by 1 times x plus 1 is x plus 1 minus x plus 1. Since we have minus, so minus times x is minus x, minus times minus is plus 1. Of course, all multiply by 1, so that 1 will not change anything. Into the denominator will be kept as x plus 1 square. So this will be written as y equal x plus 1 over x minus 1 multiplied by ln 3 multiplied by x minus x is 0, 1 plus 1 is 2, all over x plus 1 power 2. And this is the derivative. The last question I have, it's a combination of exponential function over logarithmic function. So I'll apply the quotient rule. Y prime is equal to the derivative of the top, which is ex multiplied by the bottom function as it is, log of x to a base of 5, minus the top function as it is ex multiplied by the derivative of the bottom function. So it will be 1 over x over ln to ln of 5, since we have a base 5, multiplied by the derivative of this function, which is 1. Since we are applying the quotient rule, don't forget that we need to square the bottom function. So I will rewrite this derivative again. Y prime is equal to ex multiplied by log of x to a base of 5 minus ex times 1 is ex over x multiplied by ln of 5 over the square of the bottom, log x of 5 all square. And this is the derivative. I'm Hatem Omari. Thank you for watching my video about examples of logarithmic functions. If there is something not clear in this video, feel free to watch it as much as you want. If you need me to solve any problem in math in any topic, send me a request in the comment below and I will upload the solution. If you like this video, please click like or subscribe, and thank you.